Okay, on this video, I'd like to introduce you to the 6 trig functions now that we've talked about angles on the previous video. So the trig functions are related to sides of a triangle, in particularly a right triangle has to have a right angle. And if you have a right angle, then you have 2 other angles. So let's just say this is the angle we're going to work with, which we'll call theta. And let's give this some dimensions. Let's say this side is 5. This looks a little shorter than that. How about I go 3? Now, once I tell you these 2 sides, that's really all the information I need to give you because you can figure out the hypotenuse. Remember, by the Pythagorean theorem, if you want to find out the hypotenuse, I can use the Pythagorean theorem. I can say 5 squared plus 3 squared is equal to, let's call it x squared for now. This is 25 plus 9, which is 34. So our hypotenuse is the square root of 34. Okay, so there are 6 trig functions. We're going to start with 3 of them here. So the very first trig function we'll talk about is the sine of theta. And note that we're doing abbreviations. What SIN is actually short for is SINE. That's the sine function. But we usually just use sine. It looks like sin of theta, but it's actually sine of theta. And the standard way of defining what these trig functions are is in terms of the sides from this angle, theta. We know root 34 is the hypotenuse. I'm going to abbreviate that HYP. From this angle, if you were here looking straight across or opposite that angle would be the 3. So the 3 we would call the opposite side. And the other side, which is part of my angle but not the hypotenuse, is referred to as the adjacent side. The sine of theta, by definition, we take that's the ratio of the opposite side to the hypotenuse side. So in this case, that would be 3 over the square root of root 34. Now, a note about radicals. As you move into pre-calculus, in previous math courses, you were taught to not leave a square root in the denominator, that there was somehow something wrong with that. While you might still be expected to rationalize that and not have a square root in the denominator, by and large, it's okay most of the time, especially when you move into calculus. Nobody cares if you have a square root in the denominator. So this is totally fine. Of course, we could, if we wanted to rationalize it, multiply top and bottom by root 34. And so this could also be thought of as 3 root 34 over 34. Remember, the square root times itself is the same thing. So that's the sine. The next trig function we want to talk about is the cosine of theta. COS, it's co and then sine, just like that. And that is defined to be the ratio of the adjacent side to the hypotenuse. So in our triangle, that would be 5 over root 34. I'm just going to leave it like that. Of course, you could rationalize it if you wanted to. Then we have the tangent of theta, and the tangent, abbreviate TAN, is the ratio of the opposite side to the adjacent side. So for us, that's going to be 3 over 5. Okay, these 3 trig functions, I put them in this column. I often refer to these as the big 3 because these are the ones we mostly use. The big 3. Okay. The other 3 trig functions are called the reciprocal functions. Because they literally are just the reciprocals of each of these 3 trig functions. So the reciprocal of sine is actually called cosecant, CSC of theta. And that is, as I said, that's the reciprocal. So that is 1 over the sine of theta is one way to define it. Another way to define it is if sine of theta is already opposite over hypotenuse and you do 1 over opposite over hypotenuse, you know, if you do 1 over a fraction, you just flip the fraction. You could also think of that as hypotenuse over opposite. That's totally fine if you want to. I usually just think of it as the reciprocal. And in terms of practical problems, here's the way, if someone asks me for the cosecant of an angle, what I first do is I think about the sine of the angle. And the sine of that angle we figured out was 3 over root 34. That means the cosecant must be the reciprocal. It must be root 34 over 3. The reciprocal of cosine is secant of theta. We abbreviate SEC. So that is 1 over cosine. Or if you want to, you could do 1 over adjacent over hypotenuse, which gives you the same as hypotenuse over adjacent. But the quick way to do it, if you already know cosine is 5 over root 34, then the secant must be root 34 over 5. And then finally, the reciprocal of tangent is cotangent. That's 1 over tangent, or flip, it's adjacent over opposite. The tangent of theta was 3/5. The cotangent of theta, therefore, must be 5/3. Okay. So one thing an easy way to mess up, it would be really nice if the reciprocal of sine was secant, since they both start with an S, but it's not. So you got to get these two, cotangent and tangent, that's pretty easy to remember that they're reciprocals, but it's these, the reciprocal of cosine is secant, while the reciprocal of sine is cosecant. Those two often get mixed up, so try to avoid that. Oh yeah, of course, I forgot the most common way to remember, in particular, the definitions of sine, cosine, and tangent. Many of you, if you've taken any trig at all, you've probably seen SOHCAHTOA as a way to remember the definitions. You can see it right here. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. We're just taking the first letters, and tangent is opposite over adjacent. Yeah. So that's, I think it's always funny. Most people know SOHCAHTOA, but they don't teach you the other one, which is, I suppose, Chosha cow. I don't know how to pronounce that. I guess you could do that, right? Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. Cotangent is adjacent over opposite. I never use this. I don't think you need to worry about this, but in particular, most people like to use that and then just know that if you want, for example, the secant, just take the reciprocal of cosine. So you don't really need that. That's just being a little silly. Now, just a little bit of insight into what do these trig functions actually tell us? They tell you something about the angle. What does a trig function tell us? So for example, let's say I was going to find the sine of 1 degree. And if you think about a triangle that has a 1 degree angle, it might look something like this. Where here is your right angle, there is the angle 1 degree right there. And if you think about the sine of 1 degree from here, if this was the hypotenuse, and this was the opposite side, and this was the adjacent side, one thing you could tell is if I were to do the ratio of the opposite over the hypotenuse, I'm going to take this length and divide it by this length. Hopefully you can see this is a very small number and this is big in comparison. So this should come out to be, this should be small, should be very small. Now, you're also probably aware that you have these functions on your calculator. So if you have a calculator handy and you go ahead and turn it on and evaluate the sine of 1 degree, what you will find is you will get approximately 0.017, which again, the fact that this is small, right? This is small, that reflects the fact that from this triangle, the ratio of the opposite and the hypotenuse is a very small number. Now, how that could be useful, you may also realize on your calculator that there is not only degrees, there's also radians, which we talked about on a previous video. And if you accidentally did the sine of 1 radian, I'll put note, the sine of 1 radian you may recall is about 57 degrees. That's a very different triangle. If you approximate that on a calculator, you end up getting 0.841, which is correct for the sine of 1 radian, but not for the sine of 1 degree. So I guess understanding what a trig function is could help you catch mistakes. Like if you reached for your calculator and it was actually set for radians, and you would try to do the sine of 1 degree and you got 0.841, you would hopefully realize something can't be right here, because this should have been a very small number, right? So, okay, sticking with 1 degree, what about the cosine of 1 degree? That is cosine is the ratio of the adjacent side to the hypotenuse. Looking at this triangle, if you had a 1 degree angle, this length right here and this length are going to have a very similar values, right? They're pretty close to each other. So if I took the ratio of adjacent to hypotenuse, I should be getting something that's, they're almost identical. So this should be approximately 1. Sure enough, if you plug this into a calculator, you get 0.999. So that kind of makes sense if you think about the picture. What other insights can you make? Well, if I were to ask you, get the paper straight here, the tangent of 45 degrees, you also have the tangent key on your calculator. You could work that out on your calculator, but maybe another way to approach this is to think about a 45-degree angle. How do you get a 45-degree angle? If I started with a square, where each of these two sides were the same, and we know the angles in a square are 90 degrees, if I were to make a right triangle by cutting this with a diagonal, this angle right here would be 45 degrees. It's half of 90 degrees. And then if you think of tangent as being the ratio of the opposite side to the adjacent side, you can tell that if this was really a 45-degree angle, these have to be equal to each other, huh? So this should come out to be, well, I'll write opposite over adjacent. But on a 45-degree angle, these would be the same. So I should get a value of 1. And you can confirm that on a calculator if you want to. One last thing here. Say I was to ask the secant of pi over 5, for example. Now, I'm not going to try to show you this with a triangle, but what I'm going to try to show you is you would need a calculator to do this. And most calculators, if you look at it, do not have a secant key. They have sine, cosine, and tangent. And so this is where knowing that secant is the reciprocal of cosine becomes important. The secant of pi over 5, if you had to do that on a calculator, would be 1 over the cosine of pi over 5. You could do on your calculator, you'd want to make sure you switch your calculator to radians, and the cosine of pi over 5 comes out to be about 0.809, and then you're going to do 1 divided by that, so your final answer here is about 1.236. Okay, so if you are asked to evaluate any of the reciprocal functions, you're going to want to use sine, cosine, or tangent, and then take the reciprocal of your answer. All right, on our next video, we're going to talk about how to find the sine, cosine, and tangent of some certain special angles where we will not need a calculator to find those values. 45 degrees is one of those special angles. There are a couple more too that we're going to learn about on the next video.